Hi again, welcome back to our discussion on sequences and series. In this video we are going to talk about adding up or summing terms in an arithmetic sequence or series. It's an important topic and it leads to being able to solve a variety of very practical problems. In the first video we looked at the general term for an arithmetic sequence or series and we established two things. First, that there is a constant difference between successive terms, and we can identify that constant difference by taking any term and subtracting away the one before it. Second, we were able to determine the nth term or the general term in an arithmetic sequence or series by realising that it was really the first term plus n minus one of the differences. So that gave us our computing relationship that we could use to calculate any particular term given a value of n. Now, if we're going to talk about summing terms in an arithmetic series, there's just no better place to start with than looking at Carl Friedrich Gauss, who's the greatest mathematician who ever lived. You can check him out through the index. As a 3-year-old, Carl would go and sit with his father, who was a bookkeeper. And one day, when the father had added up the 50 entries on the book ledger, Carl said, "Daddy, you've made a mistake." "Oh," said his father, "that's no good." They checked it and Carl was correct. So Carl helped his dad for a long time after that. And by the time he was 5, Carl that is, he was doing his father's accounts regularly. And then finally he went to school and drove the teachers crazy because he kept on asking questions. And so to slow him down a little bit, the teacher gave him a problem one day and said, "Now I want you to go down the back there with your slate and add the numbers from 1 to 100. The teacher thought that was going to stop him for the rest of the day. Carl was back in less than a minute. Of course, the teacher wanted to know, how come you did it so quickly? Have you done this question before?" Carl said, "No, never seen it before, but good question." So the teacher said, "How did you do it so quickly?" And he said, "Well, you write down the numbers from 1 to 100, and then you take the first one and the last one, add them together, you get 101. Take the second and the second last one, you add them together, you get 101. Do the same with all pairs that follow from there. Each pair adds to 101. So if we multiply 101 by the number of pairs of our numbers, we have 100 divided by 2, which is the number of pairs, times 101, and we get 5,050. Easy. The teacher was very impressed. So putting Carl's work into our words, we can say that the sum of n terms of an arithmetic series is equal to the number of pairs that we have times the sum of the first term plus the last term. So we can write this down as a formal statement if you wish to. Sn is equal to n over 2 times the first term t1 plus the last term tn. I think it's easier to say it to yourself like sum of n terms is equal to the number of pairs times the sum of the first term and the last term. Now, problem is we don't always know the last term, so we've got to be able to modify that formula. But remember that we've got the term Tn from our previous discussion. Tn is equal to the first term plus n minus 1 times the difference. So we substitute that in to our Sn formula, and we can simplify it to n over 2 times 2t1 plus n minus 1 times d, saying it in words so that it's more meaningful. The sum of n terms of an arithmetic series is equal to the number of pairs times twice the first term plus n minus 1 times the difference. Nice and straightforward. You've got to remember both of these because we're going to continue to work from one to another, always asking ourselves the question, do we know the last term? So let's have a look at a few examples on using the two formulas for the summation of an arithmetic series. First question is, find the sum of 6 terms of the arithmetic series minus 3 plus 1 plus 5 up to 17. We write down that T1 is equal to minus 3 and the D is equal to 4. Now the question is, do we know the last term? Yes, we do. Excellent. So it's 17. So we can use Gauss's formula. So the sum of 6 terms is equal to the number of pairs, which is 6 over 2, times the sum of the first term, minus 3, and the sixth term, which is 17. So that gives us 3 times 14, which is 42. Second example, find the sum of 10 terms of the arithmetic series, 4 plus 10 plus 16, etc. Now we write down T1 is equal to 4, the first term, D is equal to 6 because it's 10 minus 4. Ask yourself the basic question, do we know the last term, T10? No, we don't. So therefore, we use the alternative version of Gauss's formula, and we say that S10 is equal to the number of pairs, 10 over 2, times 2 times the first term, which is 2 times 4, plus n minus 1, which is 10 minus 1, times the common difference, which is 6. Simplify, 310. Easy. Now just think back to this basic formula. We have 4 main terms. One is the sum of n terms. The second is the number of terms. Third one is the first term. And the fourth one could be either D or the last term. So of the 4, they're going to give you 3 of them, and you've got to find the fourth one. Now an example of that would be this one we've got on the screen at present. The sum of 20 terms of an arithmetic progression is 880. The common difference is 4. Find the first term and the last term. So we know Sn, we know n, we know d, so we have to find T1. Substitute. 880 is equal to the number of pairs, 20 over 2, times 2 times the first term, T1, which we've got to find, plus n minus 1, which is 20 minus 1, times the common difference, to 4. So simplify that, we get 2T1 is equal to 88 minus 19 times 4, T1 is equal to 6. Now you can go either of two ways here, doesn't matter. Either you can use your nth term and say that T20 is equal to the first term, 6, plus 19 times 4, which is 82, or you can say the sum of n terms is 880 is equal to the number of pairs, 20 over 2, times the first term, 6, plus, which we just found, plus the last term, T20. Simplify that, we get T20 is equal to 82, just the same. Whichever way you see on the day, it doesn't really matter. You've got to keep your options open to say, yes, I can do it in 2 ways. How do I feel today? In summary, we have 2 approaches to calculating the sum of n terms of an arithmetic series or sequence. Always ask yourself the question, do we know the last term in the sequence or series? If we do know the last term, then we can use the sum is equal to the number of pairs times the first term plus the last term. If we do not know the last term in the sequence or series, then we use the alternative version, number of pairs 2 times the first term plus n minus 1 times the difference. So you've got to be able to ask yourself that question. So you now have the steps to be able to find the sum of n terms of an arithmetic series or an arithmetic sequence. I hope I've been able to help you clarify the approach and the techniques. Thanks for watching this video. In the next video in the series, we go to the geometric sequences and series and have a look at the general term there. Go to some of the questions in Test Yourself 1 on my website, drjsmaths.com, because what I've included there are some hints about how you can do some of the questions, because there's a whole wide variety of ways in which you can be asked questions in this area. Hit the like button on this one and subscribe if you haven't already, and click the back arrow to get back to the website. Add a comment or send me an email if you've got any questions. Good luck. See you on the geometric side.